To one and all present here. I'm Ramya Devi, working as assistant professor in SNS College of Engineering. Today I'm going to share a small introduction regarding supervised algorithms. What is supervised algorithm? It is one of the machine learning algorithms. It's a type that can be applied according to what was previously learned to get new data using labeled data and to predict future events or labels. In supervised learning, we give it a set of training data that the model learns from. It can then infer relationships between the features and the categories that we want and apply that to unseen new values and predict information about them. In supervised learning, models are trained using labeled dataset where the model learns about each type of data. Once the training process is completed, the model is tested on the basis of test data and then predicts the output. There are so many types of supervised learning algorithms, and one of the most commonly used are linear regression, logistic regression, naive-Bayes classifiers, decision trees, random forest, and support vector machine. Naive-Bayes classifiers is the most commonly used supervised learning algorithms. Here the Bayes theorem is a mathematical formula for calculating the conditional probability in probability and statistics. In other words, it's used to figure out how likely an event is based on its proximity to another event. Simply is a way of calculating the conditional probability. The probability of A given B is equal to the probability of A times the probability of B given A over the probability of B. The key insight is that the probability of something that depends on B depends very much on the base probability of B and A. Example of spam filtering. Let's just figure out the probability of an email being spam given that it contains the word free. The probability of an email being spam given that you have the word free in that email works out to the overall probability of it being a spam message times the probability of containing the word free given that it's spam over the probability overall of being free. So probability of spam or free. Spam is the event A and free is the event B is equal to B of P probability of spam of probability of free of spam divided by probability of free. Decision trees. A decision tree employs a structure of test points called nodes and branches which represent the decision being made. A node without further branches is called a leaf node. The leaf node returns class labels. Decision trees have two varieties, classification trees and regression trees. Classification trees usually apply to output variables that are categorical, often binary in nature such as yes or no, purchase or not, and so on. Decision trees, on the other hand, can apply to output variables that are numeric or continuous, as the predicted price of a consumer good or the likelihood a subscription will be purchased. Decision tree algorithms. Multiple algorithms exist to implement decision trees, and the methods of tree construction vary with different algorithms. Some popular algorithms include ID3, C4.5, and CAR. ID3 is iterative tree is one of the first decision tree algorithm, and it was developed by John Ross Quinlan. Let A be a set of categorical input variables, P be the output variable, and tree be the training set. ID3 follows the rules like a branch with an entropy of 0 is a leaf node, and a branch with entropy more than 0 needs further splitting. It uses entropy and information gain to select most informative attribute. Next is C4.5. The C4.5 algorithm introduces a number of improvements over the original ID3 algorithm. The C4.5 algorithm can handle missing data. If the training records contain unknown attribute values, the C4.5 evaluates the gain for an attribute by considering only the records where the attribute is defined. Both categorical and continuous attributes are supported by C4.5 for the corresponding records of each partition. The gain is calculated and the partition that maximizes the gain is chosen for the next split. The ID3 algorithm may construct a deep and complex tree which would cause overfitting. Next is CART. classification and regression trees, is often used as a generic acronym for the decision tree, although it is a specific implementation. Similar to C4.5, CART can handle continuous attributes, whereas C4.5 uses entropy-based criteria to rank test. CART uses the Gini diversity index defined, whereas C4.5 employs chopping rules. CART constructs a sequence of subtrees, uses cross-validation to estimate the misclassification cost of each subtree, and chooses the one with the lowest cost. Thank you.